By the end of this, you'll be standing next to something so big that light takes 10 billion years just to cross it, and scientists genuinely aren't sure it's even allowed to exist. But to feel how big that really is, we have to start small with you. So let's climb, and I promise you this, long before we reach the top, your sense of the word big is going to completely break. Here's why this is so hard for your brain. You grew up judging sizes you can walk around, a tree, a hill, a mountain on the horizon. The universe does not care about that scale at all. Every single step we take from here is going to be bigger than the last, and not by a little. By leaps so violent that the thing we just called enormous turns into an invisible speck a moment later. So take a breath. Picture yourself standing there. Ready? Step 1 is you. You're roughly 1.5 meters tall. Now the planet under your feet. Earth is about 12,700 kilometers across. You could never walk it, but you can still picture it. The blue marble. Hold on to that image, because it is the last thing on this whole journey you'll be able to truly imagine. Now our star. The Sun is about 109 times wider than the Earth. You could line up over 100 Earths across its face, and you could pour more than 1 million Earths inside it. Already, your mental picture is straining. And here's the humbling part. The Sun is an ordinary star, a small, average one. So let's meet the giants. The largest star we have ever found sits in a distant cluster, and it's called Stephenson 2-18. By some measurements, it's around 2,000 times wider than the Sun. Now, I have to be honest with you, because that's the whole point of this channel. That number is genuinely contested, and an older record holder, a star called Uy-Scuti, actually shrank dramatically once we measured its distance more carefully. That's not a mistake. That's science correcting itself in real time. But take the high estimate, if you drop Stephenson 2-18, where our Sun is right now, its glowing surface would swallow the orbit of Jupiter and by some figures reach all the way out towards Saturn. Light, which crosses from the Sun to your eyes in 8 minutes, would need hours just to crawl around this one single star. And here's the thing. We have barely started because a star, however monstrous, is still just one point of light. Now gather a few 100 billion of them, bind them together with gravity, and you get a galaxy. Our Milky Way is about 100,000 light years across. Sit with that for a moment. Light, the fastest thing that exists, takes 100,000 years just to cross our home. That impossible giant star we just met, inside the galaxy, it would be a single invisible dot. If you like having the scale of the universe unfolded for you like this, that's the whole channel. One big question every few days. Subscribe and keep climbing with us, because it's about to get ridiculous. Some galaxies make ours look tiny. One called IC 1101 holds the record for the sheer number of stars packed inside it. Another, nicknamed Alcyonius, fires jets of plasma from its core that stretch about 16 million light-years from end to end. But galaxies are nowhere near the top. They cluster together. Those clusters gather into superclusters. And our own home supercluster, named Laniakea, is about 500 million light-years wide. We only even realized we were living inside it back in 2014. Quick detour, because somebody always asks. What's the biggest single object? That would be a supermassive black hole. The current heavyweight, called TON 618, is so vast that just its edge, its event horizon, could swallow our entire solar system dozens of times over and barely notice. And yet, against what's coming next, even that is a single grain of sand on a beach, because superclusters still aren't the end. They link up into enormous glowing threads and sheets, a structure we call the cosmic web, like foam stretched across the universe. And the biggest patterns in that web have names: the Sloan Great Wall. And just recently, in 2025, astronomers mapped a colossal structure they named Quipu, stretching well over 1 billion light-years. But the largest of them all is the Hercules Corona Borealis Great Wall. By current estimates, it spans something like 10 billion light-years. That is roughly 10% of the entire observable universe. Stop and actually feel that for a second. We started this climb with you, 1.5 meters. And we have ended on a single structure so large that light itself would need 10 billion years just to cross it. Here's where it gets strange. There's a rule at the heart of cosmology called the cosmological principle. It says that once you zoom out far enough, past roughly 300 million light-years, the universe should look completely smooth, even the same in every direction. No clumps, no walls, no giant structures. Past that scale, things simply should not exist anymore. And yet the Hercules Corona Borealis Great Wall is more than 30 times bigger than that limit. By the very rules we wrote down, it is too big to be there. So which one is wrong? The rule or the wall? And the most honest answer is also the most unsettling one. We don't actually know yet. Some astronomers think the wall is real and that our models of the universe are simply incomplete. Others think it's a kind of mirage, a pattern our eyes stitched together out of scattered distant explosions. Think about what that means. The biggest thing in the universe might be too big to even be a thing. So you tell me, does a wall of galaxies even count as one single thing? I genuinely go back and forth on this, so drop your answer in the comments, because it cracks open the real question hiding underneath this entire journey. What even counts as a thing? A galaxy is a true object. Gravity holds it together as one. But our supercluster, Laniakea, dark energy is already quietly stretching it apart. It was never really bound together at all. And the Great Walls? They aren't objects in any normal sense. They're just the faint shape of where matter happens to pile up across the cosmic web, more like a coastline than a continent. So the honest answer to what is the biggest thing depends entirely on what you mean by the word. The biggest object truly bound by gravity is something like a giant galaxy or a cluster. The biggest pattern is a great wall. We can barely confirm is real. And the universe itself, the part we can actually see, is about 93 billion light-years across. Now that should sound impossible because the universe is only about 14 billion years old. So how could any light have crossed 93 billion light-years to reach us? Here's the beautiful answer. Space itself stretched while that light was traveling. The object that sent the most distant light we can see is now about 46 billion light-years away from us in every direction. And even that is only the part whose light has had enough time to arrive at all. Beyond that edge, the universe might simply go on forever. We genuinely don't know. And that isn't a failure. That's the frontier. It's the most exciting unfinished sentence in all of science. So the next time someone tells you something is huge, you can quietly smile. Because you just climbed the entire ladder. From your own height all the way up to a wall of galaxies 10 billion light-years wide. And you know exactly how fast the word big falls apart along the way. Got a question about the universe? Ask Hallie and subscribe. Because in the next one, we're asking something that sounds impossible. Could you actually survive falling into a black hole? Until then, keep looking up.